Let's make a project from this. So back to this one here, and you close it. Okay, you go to File, Project Manager. Okay, so this is now Project Manager. So you make a new project, and now you can simply just go here and simply just drag and drop. The software will be able to recognize every layer from its extension. So you can see here we have terrain now, we have image, we have clutter, we have buildings. Okay, so this is a fresh start. So go and save the project, and I'm going to save it in the same location. I'm going to call this Bristol. Okay, Bristol Airport 5G. So far so good. Now usually I need to have a PRM as well. So I'm going to populate that PRM later on. So now I'm just going to open the project. Here we go. So this is the airport. Okay, so let's import now the 5G sites, and let's do general setup for the project, and then we run the simulation after that. So step number one, I want to import the 5G sites. Now the 5G sites, I already have them here in a CSV format. Okay, so this is the inputs are here. Let me open it. So again, these 5G sites are not real sites, they just randomly generated by the software. And here we have them in the CSV format. So in the CSV format, I have some site identification. Okay, we have site address. It could be actual address. We have the longitude, the latitude, antenna height, frequency, bandwidth, and a group. I mean, you don't need all this information, but as much information as you have is better. Transmitting antenna gain, receiving antenna gain, tilting, mechanical tilting, the antenna name. So here I have antenna name. There's many ways to do that. Now here, because I'm importing omni sites and directional sites, which we'll talk about it very soon. So here I'm using the beamforming. I'm using the antenna field, and I can map this into the software, and the software will automatically assign the correct antenna pattern. Okay, matching this antenna file name. So we'll talk about it soon anyway. So first step, go to File, Import, and then Stations. I'm going to import these stations from the CSV report here. So what I'll do, I will select the file first, the source file, CSV file. Second is you need to map. You need to map the site ID. So the site ID is call sign in software. It's column number 1. You go to column number 1, you put call sign. This one is address. You go to column number 2, you put address. Okay, and so on. So I already have this prepared. So I just need to load my template. You can save a template. You see now we've got everything lined up. Cosine, address, longitude, latitude, antenna height, frequency, and antenna name. Antenna name is here, number 14. And the default coordinate system is 4dec, which means WGS 84 decimal degrees, because that's the one I'm using. Okay, I'm using 4dec. If you're using different one, then you need to use different code. So that's it. Now we need to import this, in fact, into a station database. Okay, you need to do this into the database. Now the database is not ready yet, it's not created yet. So which means you need to create the internal database. So I'm going to close this for now, okay, to show you the steps to create the station database. You go to database station here, in that menu, database station, or you can do it from here, database station database, okay. So either way, okay, either way. So you can do it from here, station database list, and then you can go here and say new, and then you can make a new one in your project, live project here. So I'm going to make a new folder called 5G sites for the webinar. Okay, so here we go. Webinar, or let's call it live 5G sites. So this is how we create a link to a station database. It's empty for now. So now we go back to import, and then we're going to import stations. So you see, I still have everything lined up. So all I need to do now, don't import to the map, import to station database. Because the coordination process is happening between station database and the radars on the map. So I'm going to import the 5G sites to the database and import the radar sites to the map itself. So it might take a few minutes. You can see, here you go, it's done. Okay, you see, it's not just the stations are important, but also the antenna, the individual antenna radiation patterns. And let me give you a hint how this was achieved. So in fact, in the software installation folder under ATDI HTZ, under HTZ, you will see here we have a base folder, something called base. Here you go. In the base folder, we have antennas. So these are the ones I used. The BFA, which is beamforming antenna.msi, and I used the omni.plt. Okay, so this is how I managed to automate the antenna importation process, because that field is matching with the antenna name I have in my database. So let's continue. So back to the software here, and then go back to the station database, and this is the database we have. Here we go, select all. So these are the 5G sites we have. Let's double check the numbers. So how many we have here? We have 241. Total 241 sites. Right click, go to parameters to check the parameters. So I can see here we have 200 watt transmission power. Now sometimes you don't have to model it as 200 watt. You need to look at your setup. Sometimes you need to do it 100 watt or 20 watt or 40 watt, depending how much overlap you have with the in-band. So we have the antenna gain coming correctly, we have transmission frequency coming correctly, antenna height coming correctly, we have antenna pattern, actual orientation coming correctly. So all the important information are in, okay? So the importation process was successful. Now you could put this on the map. If you would like to display this, you put it on the map, okay? You put it on the map like this, close, and here we go. You can go to object properties, and then ask the tool to display cosine, display azimuth, and horizontal pattern. So now you can see the actual antenna pattern, you can see the actual orientation, and you can refer to the site or the sector by its own cosine. So you could continue to set up the software. So let me now set up the radar. In fact, I'm going to set up the radar. Let's see where the radar is. I could choose really any location, but I believe the radar is here. Maybe here, maybe. Here you go. Actually, the radar here. The radar was also captured in the model. Sorry. So in the inputs here, you will notice one of the inputs is actually radar. So the radar is already in that CSV. Here you go. So the radar is the last entry, and you can see the actual frequency here, 2900, and the actual location, and it has slightly different parameters and antenna pattern. So let me go to this radar and then maybe color it in red. So go to General tab and then change this color to red. Now the radar, we don't care about the transmission power really, okay? You can put it anything, doesn't matter. And for the antenna gain, actually put it to 0 for the antenna gain for the radar, and frequency is 219, and you must use the actual antenna height of that radar. Okay, so these are the main parameters for the radar. It must be omni, and it must have 0 dBi gain, okay, because the protection is already taken care of. I mean, the antenna gain is already captured in the protection level, and the frequency must be in the range that we're looking at here. So the radar must be between 2700 and 3100. As long as it's in that range, it's okay. And the same, the 5G sites must be overlapping with that part. So 5G frequency can be anywhere, but the bandwidths must overlap with the in-band for this to work properly. So everything is in place now. We've got the radar in as red, and then we've got the rest of the sites. The orientation of the radar is not really relevant because it's omni anyway. It's rotational radar. All right. Now, the second step I want to do, so I've got the network in, 5G network, we've got the radar. Now I would like to make a vector layer, and I would like to continue to set up the project. So let's go to map vector layer, make a new vector file. So I'm going to put this vector file in, not here, I'm going to put it in the new project, live project. Here you go. So I'm going to give it the same name as the rest of the files. Sorry, not here. So it will be the same name as the rest of the files. It's going to be with a different extension. It's .rdl. Okay, Bristol Airport.vec. Done. So I created a blank file. Now also you could save your EWF, which is your network file. Save EWF. No, sorry. File. Save network file. So it's good to save all these layers. Later on, Control S will just take care of everything. So this is the live project, and then here we have this is the name convention we're using. So it's just going to be with different extension. So this is the network file. In the network file, the most important piece of information is the radar. Okay. Now the stations, the 5G stations, we don't have to worry about them if they are on the map or not, because anyway they must be in the station database, in the internal database of the software. Now if this menu this menu, if it is bothering you, this you can go and disable it from the file preferences. Okay, here you go, you can uncheck this one. So it's all good. Now, so the sites are there, the radar is there, and that vector. So I said we're going to do the vector. So I'll show you what is the idea here. I want to create circles at 1.5 kilometers and at 7 kilometers. Now 7 kilometers is the range where you need to coordinate with the radar if 5G site is being deployed within 7 kilometers of the airport. 1.5 kilometers is a sensitive area where we treat propagations as line of sight only, and we look at the reflections as well. So I'm going to use the built-in feature in the tool. You just click on the radar, you click continue, and then you go to add vector, and then you go circle. So in that circle is going to be a red circle, and I'm going to give it a thickness 3, identity number 1, and I'm going to say this is 1.5 kilometers, and give it the title 1.5 kilometer. Activate it, hit OK. Now here you go, that's your circle at 1.5 kilometers. Now make another one. You click on the station again, you go to continue, you go add vector, and then circle. This time you need to choose from here 7 kilometers, and here you need to choose 7 kilometers as a comment or a name. Okay, use the same color, same identity is okay. There we go. So now we've got 2 circles. Excellent.